Hello everyone, welcome back to my channel. I am Jitesh Ponkar, and in today's episode, we will build an agent that will resolve CPU utilization issue with the help of Prometheus, Grafana, OpenAI SDK, Ollama, and Kubernetes Python library. Now let's imagine it's 2 a.m. in the night and you are sleeping peacefully and your phone start ringing. You receive the alert by saying ship utilization is more than 95% in the production environment. Now here real work start. You wake up, you check the Grafana dashboard, you check the Prometheus metrics, you will check the Kubernetes deployment and try to understand whether you increase the ship utilization increase the resources or scale the deployment or simply wait. It's 2 a.m. So even simple decision can feel difficult in this time. So while working in DevOps, I often ask, can AI help us here? Can can AI agent read the Prometheus matrix, take a decision, perform the action, and remediate the infrastructure? This question led me to build this project that I will demonstrate this in this episode. So this is the problem statement. So also in our what we do, right, we generally keep a threshold 60%, 70% to when to scale the application or increase the ship utilization. But in real world, resource requirement vary. Fixed scaling rules are often insufficient. So what is the solution for this? So we will build an agent. This agent will get the metrics from Prometheus. We will use OpenAI SDK, and this OpenAI SDK can work with Ollama, OpenAI, Azure OpenAI, Grok, OpenRouter, any any other OpenAI compatible endpoints. So you just need to write one code and it will be compatible with all the LLM, that is OpenAI compatible endpoints. And this agent will use the LLM reasoning and based on that actions, Kubernetes Python library do the patching. This is the architecture diagram of our application. So we will deploy one application, that is CPU demo application. This application will send the metric to the Prometheus, and Prometheus will send this metric to the our AI CPU healing controller and Grafana dashboard for visualization. This controller will use the OpenAI SDK to connect with LLM. Here we are using Ollama, and with that Ollama we are using Llama 3 model. And Llama 3 will take a decision and respond the decision to controller. And then controller will use that decision with the help of Kubernetes Python library to patch the deployment. And we will patch the deployment. In our case, we will we will resolve high CPU utilization issue. So this is the workflow. So if you see this workflow, so here we have Prometheus metric. That metric will get the CPU utilization. This CPU utilization we will send to our controller. Controller will take this LLM for analysis, and here we are sending this context to the LLM to take a decision. Here, if you see, like we are specifying, if CPU utilization is more than 80%, then scale the deployment. If CPU utilization is more than 50%, then increase the CPU limit. And if CPU utilization under 50%, then don't do anything. This is the tech stack we are using. So we are using Kubernetes Minikube here, Minikube Kubernetes cluster here for container orchestration, Python for controller logic, Prometheus to get the metrics, Grafana for visualization, OpenAI SDK for LLM abstraction, Ollama to run LLM locally, and we are using Llama 3 open source model, Kubernetes Python library to communicate with cluster and perform the cluster activities. And this is our project structure. So we have agent, configuration, LLM client, Prometheus client, and KTS controller. Here we have our CPU prompt, and these are the files for CPU demo, service, and service monitor. Now let's check our code. So here if you see, this is our agent, and here we are importing configuration, then LLM client and Prometheus client, and also we are calling KTS controller. Here you can get the get replica, scale deployment, and increase CPU limit. And if you see here, we have prompt written here. So if you come here in the prompt, so here we have specified like you are an expert Kubernetes SRE AI agent, and we are specifying like that you're like these are the actions available to the this agent to, so always take actions based on this particular actions only, and we are strictly saying our LLM to do not invent any other actions. And in the rules we have specified if CPU utilization is 80%, then take a action as a scale deployment. CPU utilization is between 50 and 80%, then increase CPU limit. Right? So this is the vary we are doing. So 50%, 80%. If you use traditional system, then it will you can only set the 50% or 80%, not both. So it is the vary. So you can use this type of like vary requirement which with the help of LLM. And then like we are also specifying you must follow these rules exactly. Do not invent action. So by writing this type of prompt, we will make sure that our agent will respond the exact same output every time. Now let's go back to the our agent, and if you see here, so now let's go to the configuration first. And if you see here, we are using our Prometheus URL. This is localhost URL we are using. This is prod namespace. This is our deployment and check interval. So in every 30 seconds, our controller will check the status of the pod. And here if you see, so we are, it is OpenAI compatible endpoint we are creating. This is the base URL and API key and model that we are using. So here like we are using Ollama to run LLM locally. That's why we are using localhost URL here. And if you are using like OpenAI, maybe Azure OpenAI, then you have to specify this URL here, and then you have to provide the API key here. So you don't need to change anything here. You just need to change the base URL for your LLM and API key, and you can use this demo directly. Then if you go to the LLM client, so here if you see we are using OpenAI SDK, and we are now sending the base URL, API key and model that we have specified in the configuration, and we will create the client for the OpenAI, and we will send this prompt to our LLM. So now if you come here, this is our controller, okay, and now let me explain this last action. So what I am doing, right, so I don't want to be repeatedly scaling my application or resources or replicas. I want to make sure that it will not prevent the same it will like I want to prevent repeated action using the last action. So in production what you can do, so what is the task, right? So if let's say CPU utilization more than 90%, then it will scale the deployment. and again in every 30 seconds, because we are continuously putting the load, so it our CPU utilization always been 100%. So we don't want to our LLM will take the because LLM will take the same decision every time, and our controller will try to scale the deployment or increase the resources depending on the um, LLM or LLM decision. But to avoid these type things, we are using last action. In production, what you can do, you can use the cooldown period like 5 minutes or 10 minutes. If the if CPU utilization is still not go below the your threshold, then your controller again will take the appropriate action. So here, if you see, here we are certain CPU healing controller started. It will check the CPU health, and then if you come here, like, so you will get the uh, CPU utilization percentage from Prometheus client. So if you see, this is the query you are using. So this is the container CPU usage seconds we will get, and that we will divide it by the kube container resource limit, and we will multiply by 100. So it will give us the CPU percentage. In Grafana also we are using the same query to get the metric there. And here you are sending the Prometheus URL and our API key, our API and query, and it will send us, it will give us the CPU utilization metric. Now if you come here, so we are putting like and if you come right, so here you are building the prompt. Okay, so in the prompt you have specified the what rules he has to follow while taking the decision, and also we along with that file we are also sending deployment name, CPU utilization, and current replicas to the LLM to take a better decision. And we are also sending this prompt. So with the help of this data, our LLM take a decision to increase the CPU utilization or scale the deployment. Now if you come here, so we are putting like consulting AI, and here we are sending this prompt, and this prompt will go to the here and it will take the decision. Now let's come back here, and if you see here, like it is scaled in deployment, so it in the decision, then it will scale the deployment. So here, like you can see here, like this is the last action to the equal to less scale action. Then you can say like deployment already scaled recently, and it will skip. This is the same way we will do the increase CPU limit as well. Now let's check the requirement file. So we are using Kubernetes and request an OpenAI library. This will all will get installed using requirement files, and this is now our demo application. And if you see here, we are using one replicas, and then we have continuously putting this trace to our agent, so that it will keep putting the load and increase the CPU utilization to 100%. And now initially we have stored the CPU utilization is initially we have specified resources 100 M CPU and 200 M limit. And now if you see, this is our service for our deployment, and this is service monitor to monitor our service to get the metric. Okay. Now let's come back to our GitHub, and if you go to the Grafana, it was an initial state. Okay. Now if you see here, we don't have any data, so we don't have any CPU utilization in the pod running because we are not running our pods yet. So now let's deploy our application. Okay. So if you see, now we will follow the our guide. So these are the prerequisites you have to follow. So you have to install the Docker, then Kubernetes minikube cluster. You can use the kubectl, Helm, Python, and Ollama. So here are the steps you can follow. This command you can use to install the kubectl command, and you can verify this command using this command. You can verify the kubectl version using this command. So if I run this command, you will get this this type of output, and then you can install the Helm using this command, and you can verify this version like this. So I already installed Helm in kubectl, so I will skip the steps. And then like you have minikube cluster, then you can start the minikube cluster using minikube start, and to make sure that it is running, you can use this command to get the nodes. If you get this type of output, that means your minikube is running. Then this is the two namespaces you have to create. So let's create prod namespace. So I got the error because I already created this prod namespace, and then you can create the monitoring namespace as well. Yes. So in this way you can create the Prometheus and Grafana, and with the help of this command you can get we can install the Prometheus from this repositories, and then after installing that you can verify that your monitoring, alert monitoring, Grafana and your Prometheus is running. Once that is done, you can access the Grafana with the help of this command, and it will be running in on this 3000 port. And you, as you know, right, we can install the Ollama using this command. So let's install this. Yes, so your Ollama is installed. Now you can pull this model. Let's clear and run. Your model is pulled. Now you can verify this using this command. So if you see here, like, so we are using Llama 3 latest model, and here interesting thing is that if you see here in the parameters, so let me little bit zoom out. Okay. So now if you see here, right, so we have model Llama 3 latest, model latest, and this is the size of our model. And if you see here, we have parameter size, that is 8 billion. So it is very lightweight open source model you can use. Now let's create. Okay, so now we have to start with the demo. So let's do. So now first you have to clone this repo. Let's clone it. So now if you see here, we don't have any repository. So now click git clone. Then we will, after clone this repo, we have follow all the steps. So we will directly come here and set up the environment. So first we will create the environment for Python and then activate the environment. Okay. Once that is done, just run this command to install your requirements. So I am not in the repository, that's why it is saying. Okay, now let's install. Okay, so installation is done. Now let's deploy our application. So now if you come here, so if you see get pods -n prod with not kubectl get pods. Okay, so you say we don't have anything in this namespace. So now let's deploy. So first you have to go to the name in the folder structure, and after this command. Now if you see, we will get the deployment here. Okay, and now if you come here in the Grafana, still we don't have anything here. So let's wait for 1 minute. You will start seeing the CPU utilization and pods running count there. Okay, let's wait, and now we will see. Okay, once with that, we will let's install the service, and then install the service monitor. Okay, we have both deployed now, service and monitor with along with our application. You can also verify in the Prometheus using this. You will post forward with Prometheus to access your Prometheus on 990 port on localhost. Okay, here what I was saying, like I'm using the same Prometheus query in Grafana as well that I was sending to the or LLM. So we have same source, that is Prometheus, for the LLM as well as our Grafana, and this is the query for running pod count. Now let's check if we start. Yeah, so if you see here, right, so now we have one pod is running and our CPU utilization is 100%, around 95%. So because we are continuously putting load, so it is making sure like it is continuously keep CPU utilization 100%. So now let wait 1 minute more. So if we will get 2 to 3 data points, and then we can start with our agent. So now our agent is ready. So now first clear this, and now also clear this as well. So now if you see, right, so we have one pod running is only, and here also we are enable the environment and install the dependencies. Also we are seeing data points in the Grafana. Okay, so now if you see one pod is running and CPU utilization is 100%. Now according to our theory, we were like we have written in the prompt. So if you come here, according to this prompt, what we are saying, that if CPU utilization is more than 80%, then scale the deployment. So we are expecting our agent should take the action as a scale deployment to increase the CPU as per the requirement. Now let's run our agent, because now we have data point. Okay, and now one pod is running. So now let's our agent Python and agent.py. Okay, now you can see our agent started. So if you see, you can see here like CPU utilization is 100% and CPU source metric, so it is Prometheus. Okay, yes, so here you can see our LLM will take a decision to scale the deployment because CPU utilization is above 80%. So according to the rules, we should scale the deployment. And here you are started the scaling the deployment. And if you see here, now you can see like in 20 seconds ago we have new pods. Okay, and if you come here, you can see we have two pods started running, and here also we will in some time also we will see the CPU drop here, because we are not completely see the drop because we are continuously putting load to the CPU utilization, and because of that you will not see the drop in the Grafana in CPU utilization. Yes, if you see here like so now it is 71%. Okay, because now we have two pods and here is a CPU utilization drop, and this is what if you see, so it is 100%. Now after scaling it is only 70%. Okay, 71%. And if you see here like what continues here, only two pods running. Okay, so this is here like we have dropped the CPU utilization and we have scaled the deployment. Okay, based on the rules. So if you see here like because in every 30 seconds it will check, so and we are continuously putting load, so it will get again, it will get the 100% utilization and it will try to scale the deployment again. But as I already explained, right, so we have used that last action to make sure that you should not be scaled repeatedly. So here now it is also detected 76%, but it will not scale again because recently we have scaled the deployment. In the production, you can use the cool time period, because now why it is happening, because we are continuously putting the load to make it 100% for simulation. So now if you see, so view towards, yes. So now let's go back to our, so these are the key learning, right? So in this project, what we have demonstrated, so we have Ollama, OpenAI, Azure AI, and Grok, Open Router. These are all the things you can use with the help of this OpenAI SDK. And that's it for this demo. So if you like this video, then please subscribe to my channel, like this video, and you can also start this repo for your reference. Thank you.